Hurricane Dora happened in early August of 2023. And that's interesting because that particular season was the start of what we call an El Nino year, or an El Nino season. And I'm not going to go too much into El Nino and La Nina, but the basics in terms of how it impacted Hurricane Dora is we typically associate during El Nino periods warmer Pacific Ocean temperatures. And so it would make sense then that that warmer temperature would then produce a hurricane in the Pacific Ocean, as was the case with Hurricane Dora, which first became a hurricane somewhere in this general area here, and as I'm getting ready to show you, actually formed over here. Hurricane Dora is interesting in the sense that it is a Pacific hurricane that then crossed the international date line, so went so far across the Pacific Ocean that it became a typhoon. It actually ended up kind of fading away. It's kind of its hurricane death, so to speak, was there over in the Western Pacific, not that far from Guam, not that far from Japan, and really not too far from the Asian landmass. But the origin of Hurricane Dora goes way back to off the coast of Africa, like so many of our hurricanes. And so although it's a Pacific hurricane, it actually has the same source area as all the other hurricanes that we observe. They all come scooting off the African coast, maybe as clusters of storms that eventually fire up. Could be because of warm waters, could be because of lack of wind shear, lack of something stopping it. So those are the characteristics that we're going to see here. So we go back to August 1st or 2nd of 2023 is when Hurricane Dora first became a hurricane in the Pacific Ocean, just off the coast of the Baja Peninsula there in Mexico. So if you've been to Acapulco, not too far from Acapulco, south of California. So that's where the hurricane originated, but we'll try to figure out where it started and when it started. So here I'm going to go back to July 11th, 2023 in this particular video. That's showing me Atlantic hurricanes. And so July 16th, right about now. And so we have this cluster of storms, this low pressure area that's coming across the Atlantic, and typical, very normal low pressure areas. And then all of a sudden starts picking up some steam. And so lack of wind shear helps it come through these particular islands of the Caribbean, comes across Central America, and then right here when we're in the extreme eastern Pacific, go ahead and pause it, there's Hurricane Dora. So its origins began, like so many, as a cluster of storms coming off the African coast, scooting across the Atlantic, coming into the Caribbean Sea. Once again, helping to intensify it as we got some warm waters, particularly in this time of year, here in August in this particular area of the world. I went and I found the Hurricane Dora report to use for my research here, and I went ahead and I went to this table here. It tells me when everything and where, all this particular information. So date, time, UTC, so it was on the 31st of July. 31st of July at 1200, we have a low pressure, and then just soon after it became a tropical depression. It then also gives me the latitude and longitude, and of course as we go through over time, the pressure goes down and the wind speeds go up, which we would definitely associate with a hurricane formation. Alright, so I'm going to go ahead and I'm going to go back to this wind map, earth.nullschool.net, and I can go over here. Let's go take you back. If I go to this little calendar icon right there, I can go back in time to 2023. We'll go to that particular time, late July, 1200 UTC. 1200 UTC, so it takes me right there to that particular time. And so I got to find lat and long. So 14.3, 102.6. So I can kind of click around and see how it tells me. All right, I'm getting closer, getting warmer. 14.0, I'm going to go and zoom in. 102. And here is our tropical wave. Very characteristic shape of our tropical wave. And so here's the early formation of Hurricane Dora, as I can see here in this wind map going back to that particular time. If I look at the mean sea level pressure, I can see probably that the pressure is lower. We see darker colors. So the pressure is going to get lower and lower over time. And I'm going to see if I have any precipitation associated with this. And of course I do, with this disturbance here, this tropical low. Now I'm going to go ahead and go forward in time. And I went to 1800 UTC, which is what we see there, 1800. So now it is a tropical depression. And so most definitely that is a tropical depression. We can see that rotation. So this is clearly the low pressure is starting to strengthen. Now I'm going to go forward to the next day. We have 600 UTC, 600, and that's when we have a tropical storm. So now the winds are strengthening, the pressure is dropping, and we see Hurricane Dora is approaching as far as its formation. It soon will be the birth of a hurricane. And now we have August 2nd at 0 UTC. And that's reflected here in my wind map. And now with formation of a hurricane. And as far as its Latin long, it's pretty obvious where it's located. And now I can say, okay, as far as the path, where is this headed? Well, we can see as far as its origin, where I first put that dot, where that low pressure was identified, that tropical wave, it's moving westward, slightly to the north. So we'll say slightly northwestward. More west than north, but it's moving in a particular pattern that we would expect, east to west in this particular part of the world. And now if I go ahead and I'll look at the mean sea level pressure, we should see a dark color there, and that's definitely observed. We should also expect precipitation, and we're starting to get that very distinctive pinwheel shape. And I'm going to go ahead and I'm going to go back to the wind and go up to a higher elevation, or a higher altitude I should say. We'll go ahead and go there. And what this is indicating is there's really nothing blocking it. Okay, like I said earlier, it's moving from the east to the west, and as the upper level winds, are they helping to stop it? Are they helping to come? Are they coming from a different direction? No. And so that's going to help this sucker just only starting to strengthen and move, and it moves a long distance over a long period of time, but it does really minimal damage. It does minimal damage because it's in the middle of an ocean. So there isn't much in the way of this particular hurricane. So that's also going to help it keep it going. So there's nothing essentially blocking it in terms of wind, but also land areas helping to slow it down. And it's also going to be over warm waters for a good amount of time. And its steering mechanism is just kind of just moving it right across the Pacific on its way to the western side of the Pacific Ocean. Here's the Hurricane Dora path, beginning with its origin as a tropical wave, as I just noted. And so the 31 is just denoting July 31st, and then the white dot is at 1200 UTC, and then the black dot is at 12 hours later at 000 UTC. So these are in 12-hour intervals, and so you can see how the hurricane moved relatively slowly, but also over a large amount of ocean water and a large amount of time. So it was August 17th until it was essentially no longer. So this is a very abnormal, it's not normal for this long of a hurricane event. We can see the lowest pressure observed was down here, 939 millibars. That would have been on the morning of August 6th, or overnight, August 5th and 6th. And so this was its particular path, and so the colors are labeled here so we can see how it quickly went from a wave to a depression to a storm to a hurricane to a major hurricane. It then had a kind of a lull. It had a what we call an eye wall replacement cycle. Essentially, the hurricane momentarily died down, and what was happening, there was a little bit of encounter, just a little bit of wind shear. There's a little bit happening down here below it, kind of slowed it down just a hair, but then it picked back up again, re-intensified, and quickly that pressure dropped. Eventually it passed 140 degrees west. That's interesting because we are no longer in the eastern Pacific. We are now technically in what they call the Central Pacific. And it scooted across as a major hurricane through the entire Central Basin. Eventually we get to the international dateline. International dateline corresponds roughly with 180 degrees. So essentially that's where we go from Western Hemisphere to Eastern Hemisphere. And this is also where then we enter now the Western Basin of the Pacific Ocean. Very abnormal. I mean, once every 5, 10, 15 years do we have a hurricane actually cross the eastern, central, and western basins of the Pacific Ocean. So here was an interesting characteristic of Hurricane Dora. So what that means is crossing the international dateline as we go from being called a hurricane to a typhoon. So this became Typhoon Dora at this point here when it crossed 180 degrees, or essentially crossed the international dateline. If I go back to the wind map, going back to that particular time in which it had that lowest pressure, that lowest reading, that lowest mean sea level pressure. And I go ahead and I zoom in the middle here. It's showing me 958. It's showing me a very low number there. So that's probably the lowest you're going to find when you track Hurricane Dora in its path. All right, I'm going to go look at the wind, and of course we see very, very high wind speeds associated with that, especially there along the eye wall. Let's kind of get an idea how big this sucker is. So let's look at precipitation. Really not that big at all. So if we think about, okay, what makes this particular hurricane unique? Like I said at the beginning, every child is unique, every student is unique, every hurricane is unique. But for the most part, we have general characteristics that are the same. So this is a general characteristic. Of course, it traveled east to west through the tropics in this particular area of the world. Very predictable. It intensified as it went over warm water. Very predictable. It helped to be moved by the lack of wind shear. Very predictable. However, this sucker had a very long path over a very long duration, but was relatively small in terms of its size. This isn't something which takes up a large area like the other recent hurricanes that we've observed. Now let's take a look at this hurricane as it moves by the Hawaiian Islands. It's very interesting. And so this is that same time I just mentioned, August 6th, at the beginning of the day, and we're going to go just over time and take a look at Hawaii, particularly this island right there. That's the island of Maui. So these are the Hawaiian Islands, the big island, and the next island to it is the island of Maui. That's where there was these wildfires that were kind of already starting. There's maybe some of them that were caused by people. So there's already a dry atmosphere during a dry period. If you've ever been to this part of the world, Maui, in this particular area of Maui, it's quite dry. It's because of orographic precipitation creates a rain shadow effect, and so Lahaina and the nearby wooded areas, it's quite dry throughout much of the year. Now they do of course get occasional rainstorms and all of that, but we had a very dry condition combined with high wind speeds that were associated with, going back to something we talked about early in the semester, the pressure gradient force. Once again, high to low. So up here we have a high pressure. We know that by its spin clockwise. And down here we have a low pressure. So pressure gradient force, high to low. And so what's going to happen is this hurricane, what it's doing is essentially taking the air from that high pressure and it's sucking it in. It's bringing it in quite quickly. And so we have very predictable patterns. It's quite normal for there to be high wind speeds in the Hawaiian Islands. After all, surfing. People surf out there. You need wind to move the waves. So it's not abnormal to have high wind speeds. It's just extremely high wind speeds created from the pressure gradient force. I'm going to move this sucker over time, and we're going to see really these winds come right across and move closer to the Hawaiian Islands. And so this is when we really start getting closer to that time period of the ignition of the wildfires that then burned the Lahaina to the ground. I'm really surprised we haven't talked much more about that. I mean, that was such a big event, and it's kind of just quietly gone away for some reason. I also want to show this because it's quite normal for us to have low pressures in the Pacific. But of course, what makes this one unique and different is the wind speeds much higher here than you'd find there for these low pressures, and also the pressure area is much lower as well. So I'm going to move this just further. So as this particular hurricane scooted by the southern side, I don't know, that's probably about 100 miles, 60 miles, would say, to the south of the Hawaiian Islands. So it never made landfall. However, it still indirectly kickstarted some of those wildfires and eventually the devastation there in Lahaina.